Cat Talk slow version. Inside your computer. Do you remember when you first realized that your computer was more than just a monitor and keyboard? That between the mouse click and the video playing, there is something that captures your intention, understanding, and made it real? What is that something? Is it gremlins? Let's imagine that we can shrink down to the size of the electron and inject ourselves into a click of a mouse. If you took your mouse apart, you'd see that it's really a very simple machine. It has copper buttons and a system for detecting motion and distance. You might have an optical mouse that makes its measurements, white bloods, and sensors, but all the ones did this with a whole rubber ball and some plastic wheels, same contacts. When you click the button on your mouse, it sends a message to the computer with information about its position. When your mouse clicks and receives, it's handled by the basic input-output subsystem. This subsystem acts as like eyes and ears and mouth and hands of the computer. Basically, it provides a way for a computer to interact with an environment. But it also acts like a buffer to keep the CPU from being overwhelmed by distractions. In these cases, the I/O substances decides to your mouse click is pretty important, so it generates interrupts to the CPU. Hey CPU, gotta click here. The CPU, or Central Processing Unit, is the brain of the whole computer. Just like your brain doesn't take up your whole body, the CPU doesn't take up the whole computer, but it runs the show all the same. And the CPU's job, as a whole job, is fetching instructions from memory and executing them. So while you're typing maybe really fast, like 60 words a minute, the CPU is fetching and executing billions of instructions a second. Yes, billions every second. Instructions to move your mouses around the screen, to run the clock watches on your desktop, play your internet radio, manage the files you are adding on the hard drive, and much more. Your computer CPU is one heck of the multitasker. But oh my gosh, there's a very important smart click coming through now. Let's drop everything now and deal with that. There are programs for everything that CPU does. A special program for the mouse, for the clock widget, for the internet radio, and for dealing with letters sent by the keyboard. Each program was initially written by a human and human-readable programming language like Java, C++, or Python. But human programs take up a lot of space and contains a lot of unnecessary information to a computer, so they are compiled and made smaller and stored in bits of 1 and 0 in memory. The CPU realized that it needed instructions for how to deal with this mouse click, so it looks up the address for mouse program and sends a request to memory subsystem for instructions stored them. Each instruction in the mouse device driver is duly effected and executed. And that's not nearly the end of story. Because the CPU learns that the mouse was clicked when it cursor was over a picture of the button on the monitor screen, and so the CPU asks memory for monitor program to find out what the button is, and that the CPU has to ask memory for the program for the button. That means the CPU needs the monitor program again to show the video associated with the button, and so it goes. And let's just say that a lot of program involved before you even see the button on the screen light up when you click this. So just a simple task of clicking your mouse, meaning visiting all the critical components of your computer architecture. Peripherals, the basic input-output system, the CPU, programs, and memory, and not one gremlin.